Welcome to this webinar on Google Analytics Data Mining with R. Brief introduction about your speakers for today. I am Kushan Shah. I am a web analyst at Tattvik and I also contribute to the RGoogleAnalytics Library. We'll be talking about RGoogleAnalytics during the course of the webinar. We also have with us as guest speaker today Andy Granowitz. Andy is a developer advocate at Google. Hi Andy, thank you for being with us today. We have received a lot of comments from all of you and we have tried to tailor the content of the webinar in line with your comments. So we'll be beginning with a brief introduction to R and then we'll try to understand why R and Google Analytics data are a good match for each other. This will be followed by a brief demonstration of how to use R Google Analytics to extract your Google Analytics data into R, and then we'll be following it up with a couple of real-life applications of Google Analytics data and analysis inside of the R environment. At the last, we'll have a Q&A round. So R has gotten a huge interest lately within the analytics community, and to begin with, R started as a statistical computing language and now it has branched out to many different applications. R is being widely used by a lot of organizations in a variety of verticals, be it internet companies, be it e-commerce, be it pharmaceutical companies. All of them are using R to solve a lot of the data problems. But it is interesting to note what kind of problems can be tackled with R. Some of the problems fall into these categories. So you might have a very normal data analysis problem in which you might want to slice and dice your data into different segments, compute aggregates, sums and counts, and then draw inferences from all of them. This can be definitely done, be executed with the help of R. Apart from that, if you wanted to visualize your data, you could use R's ggplot2 package to visualize your data in a very sophisticated way and make very professional graphics. Apart from that, let us say you wanted to apply statistical tests to your data. For example, if you had results of an A/B test and you wanted to compare which version performed well over the other, then these kinds of statistical tests can also be executed with the help of R. Aside from all the exploratory analysis techniques that we just mentioned, if you wanted to take your analysis a notch further and execute predictive modeling in R, R is also capable of helping you in these use cases. So use cases like a recommendation engine, predicting the click-through rate for your advertisements, some of these models can be executed with R. Forecasting of your time series data and your business metrics is also possible with R, and we currently have an example in the webinar in which we'll be showing you how to forecast your product revenue from historical data. So our goal today is to give you a 10,000 feet view of R and show you some of its capabilities, mainly in data analysis, visualization, and forecasting. And so we have tried to pick one example each from all of these categories. Next, we'll see why R is a good fit for all these kinds of problems. The first step in any analysis is to actually bring your data from your source inside to the tool. And R is very versatile in this respect, in the sense that if your data resides in the form of a flat file or in a database, or let us say if you wanted to integrate with an API and query data over a web service, R makes it very simple to integrate with all these variety of data sources. Once you have gotten your data from your source to R, it resides in a data structure called a data frame. You can consider a data frame as an analogy to an Excel spreadsheet or a MySQL table. So think of all the operations that you perform on an Excel spreadsheet: pivot tables, filtering, sorting, VLOOKUP, and so on and so forth. All of these can definitely be replicated with R. One of the other advantages or one of the other driving forces behind the adoption of R is the presence of a very active developer community. So since I just mentioned, R started with its roots in the statistical community and then branched out to being adopted by a large other number of domains as well. This had partly to do with some of the academics and statisticians contributing their research in the form of R packages, and the community has actively picked up this trend. Today, an estimated of 6,000 packages are already available on R's central repository, which is called CRAN, and these packages encompass a lot of different domains. The advantage of having a large number of packages is that whenever you sit down and want to prototype a certain analysis, for example, if you wanted to execute a predictive model, then you don't have to necessarily reinvent the wheel and implement algorithms yourself. Algorithms are already implemented, and you can basically apply those algorithms over your data. So this was about that R being an open source language. There are no software licensing costs associated with it if you compare it to counterparts like SAS or SPSS. Last but not least, R scripts enable you to reproduce your analysis over a wide number of data sets. So it drastically improves your productivity as an analyst as well. So we covered a brief introduction to R and covered some of the facets as to why R is a good fit for your data analysis routines. But what makes R so special for Google Analytics data? So being an analyst, my daily workflow involves logging into Google Analytics user interface in order to answer some business question with the help of data, or in general to just get a health check of how my data is performing. But in this case, let us say if I were to export my data from Google Analytics from the user interface into into a CSV file, there are certain limitations associated with this process. The first and foremost is the case that Google Analytics user interface allows you to export only 5,000 records at a time in the case of your pre-canned reports or your custom reports. Moreover, the custom reports that you are able to build in Google Analytics user interface are only capable of including 4 dimensions and 7 metrics. So if you, for these kinds of use cases, the API has a lot more flexibility in the sense that with the Google Analytics API, you could create reports having 7 dimensions and 10 metrics, up to 7 dimensions and 10 metrics. Moreover, if you wanted to extract your data overnight, you could just fire off a script to interact with the API. It would extract the data overnight, and then you could log into work, and then these kinds of batch data extraction routines can also be very well executed with the help of the API. Apart from that, since the number of dimensions actually tends to increase the number of records in your queries, so API is also very well suited to handling large queries, and in the case of large queries, they might span 10,000 records to 1 million records and beyond. Now, we compared and contrasted the API versus the user interface. But as an analyst, if you have to manually interact with the API, there is usually a lot of low-level routines that have to be managed. One routine could be you would have to manually authorize the application with the API. Then, since the API returns a response in a specific JSON format, it has to be translated into your application. And this sort of a void is where RGoogle Analytics fits in exactly. So RGoogle Analytics is an R wrapper over the Google Analytics API, and it gives you high-level functions to easily interact with the Google Analytics co-reporting and the management API. Under the hood, it takes care of all the low-level plumbing that I just mentioned. A bit of background into RGoogleAnalytics. It actually, RGoogleAnalytics started out at Google as a project by Michael Perman and Nick Michalowski, and it was picked up by a couple of additional volunteers, including myself, and I currently maintain the package on CRAN and GitHub. Now, on a very tangential aspect, if you are Google Analytics Premium user and you regularly export data to BigQuery, since you have a very large data and you want access to hit level data, you might be using BigQuery and a combination of Premium and BigQuery. In the case where you want to analyze this data into R, you could try looking at the big R query package developed by Professor Hadley Wickham. It provides a high level, it is similar to RGoogleAnalytics, but it provides an API. It is a wrapper over the BigQuery API as such. So hopefully I have been able to drive home the point that using Google Analytics API is well suited to certain workloads wherein you require access to a large quantity of data, and you want to repeatedly access that data over a certain period of time, maybe periodically analyze the data, so on and so forth. With that, I think we're in good shape to start with a quick demonstration of our Google Analytics and show you a sample query and an R script along with it. So before we do that, here is the environment setup required. You can install R from the R project homepage, and as such R is a command line application, but for beginners and even for a bit intermediate users, it is good to start with a GUI. RStudio provides a very intuitive GUI for R, and you could also install it after installing R on your environment. Then we can install R Google Analytics, and I'll show you how RStudio looks like and how this installation can be done. But there's one more step required before we can jump onto the execution. So you need to whitelist. You need to first create a project in the Google Developer Console and whitelist that project with the Google Analytics API. This ensures that you get a unique client ID and a client secret, which you can definitely paste it into R and then kick off the authorization routine. So I'll quickly jump to RStudio. So this is how the RStudio interface looks like. There are 4 sections on the screen. The first section is where this particular section on the left is the scripting section, and all your scripts can be written over here. All the commands that are executed as a part of the script, they get echoed in the console. And you could also use the console to access some of the help. For example, if you wanted to get help for R, you could append a question mark to some of the commands that you want to view the documentation for, and the documentation gets displayed in this help section over here. All the plots that you make also get displayed, and the environment is where you load the data sets and all the variables associated with those data sets as well. So I'll give you a walkthrough of the R Google Analytics data extraction script. This script is already present as a part of the R package itself. We begin by loading the R Google Analytics library. And since I just mentioned the client ID, client secret also have to be loaded in memory, and this is used to carry out the authorization routine. Why this is essential is because all the API requests need to be authorized, and the client ID, client secret gives us a unique access token which is appended to each and every API request. But all of this is handled under the hood. It's just that we need to get the token first, and the token is directly appended later on. R will ask you whether you want to cache the token in a local file, and it will then redirect to the browser. So once it redirects to the browser, it will ask you to log in into Google Analytics, and it will ask for a certain set of permissions. The first being the permission to view your reports, and the second being to view your configuration information. This is a one-step authentication that is required to be executed only once. So now that we have the access token, we can actually start entering the query parameters and start with the data extraction. So the normal query parameters which are mandatory are the start date and the end date for a query. In this case, what we're trying to do is we're trying to extract the item revenue, which is broken down by month and year, for a period of January 2011 to December 2014. We are also sorting the results by year, and table ID is the parameter in which we need to mention the profile ID or the view ID for which the data extraction is to be carried out. So we initialize the query, and we need to validate the parameters so that R can just do a quick sanity check as to whether we haven't missed out on any of the mandatory parameters. Finally, the getReportData function takes as an input the query that we just made and the token, and it will fire an actual query to the Google Analytics API and get the data into this object called ga.data. So the status of the query says that the API returned 48 results, and will quickly view the first 6 rows and check whether the results are appropriate or not. So we can see that the results actually correspond to the query that we just executed. So this was a very brief introduction to RGoogle Analytics, and this is more or less all that is to it. There are various options. There are additional options over here. You could try and experiment with various filters and segments, and apart from that, there are also a couple of more options that we'll just talk about in a bit. So now that we have understood the data extraction and gotten the gist of what RGoogle Analytics is, we can now begin with some of the examples. In the first example, we'll try to forecast product revenue for an e-commerce store that is running Google Analytics. In the second example, Andy will try to explain how you can assess the long-term value of your marketing campaigns. And finally, in the third example, I'll do a quick analytics visualization setup with the help of the ggplot2 package. So we just extracted product revenue data as a time series, and we want to utilize this time series to build a historical model for product revenue, and then use this model to forecast the product revenue for the next quarter. So as an input to this, what we have is time series product revenue for the months of 2011 from 2011 to December 2014. And in the first step of the analysis, we'll try to make a quick plot and understand the basic structure behind the time series. So there are three prominent peaks associated inside the time series. The first peak over here occurs between November to January 2012. The second one also occurs between November to January 2013. There is one additional peak in the year 2011 in the same duration. This one over here is a bit of an outlier. And so we can see that, okay, these three peaks are regularly are co-occurring at a very periodic, at a fixed interval of time. And the nature of this data is that since it's an e-commerce store, there is holiday shopping associated with it, and that is why we see these prominent spikes during the end of the year. So apart from seasonality, the other one of the other aspects that come out of the time series is that there is a long-term increasing trend inside of the time series. So these values are actually fluctuating somewhat around this line. So these seasonality and trend are, they give us a very fair idea of the structure of the time series, and we'll be using both of these concepts to forecast the next quarter values. So the first step to forecasting is to decompose the time series into the components that we just saw, and this is a quick plot of how the decomposition looks like. So in the first row over here we have our actual data. In the second row, this data is broken down into seasonal components, and in the third one it is broken down into one additional component, which is the trend, and the remainder component is the random variation or the noise associated with this particular time series that we have. Now I'll transition to R, and we'll use both of these concepts to build a forecasting model. We'll be using the forecast library, which is developed by Professor Rob Hindman. Quickly load up that library into memory, and since you have already extracted the data in this particular object called ga.data, the next step is to transfer the item revenue into a time series data structure. This is done with the TS function, and the arguments are, we need to tell the vector in which the data is contained. We need to also give it the start and the end months, and also mention the frequency of the time series. So once our data is contained into a time series, we can do a quick sanity check and confirm whether the time series is actually appropriate. So that is it. And next we'll decompose the data into the three components that I just mentioned using the STL function, and we'll reproduce the plot that I had appended into the presentation. So these are the three components. Now the main function which we'll be using for forecasting is the ETS function, and it uses an exponential smoothing model. Going into the math of exponential smoothing is a bit out of scope for this presentation, but at this point I can tell you that the first step to making a model is to decompose a series that we just saw, and the second step is to use the interactions between the seasonal trend and the noise components in order to determine what would be the next set of values for the next period. ETS actually does a lot of stuff under the hood, and you could actually go into the documentation and experiment with some of the other additional parameters that it has. But let us start with creating a very basic model and assessing whether that model is a good fit. So this model is now saved into an object which is called fit, and the first check to whether this model is valid or not is to assess the residuals of the model. The residuals are the difference between the actual and the predicted values, and we need to confirm whether these residuals are randomly distributed over time, which we'll just do by plotting these residuals. So here, until this section, until 2014, we see that, okay, more or less these residuals have a random variation around the center line, and their effects tend to cancel out each other. This particular spike over here, it occurs due to the outlier that we just saw. But since we are only concerned with creating a very basic model, that should be okay for us as well. Next, we'll use this model as an input to the forecast function and predict or forecast the values for January 2015 to March 2015. So we'll quickly inspect this forecast object. So this forecast contains 3-point forecasts, and there are also 95 and 80% prediction intervals which contain a range of values. So next, we'll line up the forecast with the actual values and see how they line up with each other. So the black line shows the input values that we gave to the model. The blue and the gray show the forecasted values and their ranges. So this particular value is the forecast for January. This one over here is for February, and the final one for March. So since there were prominent spikes in the months between December to January, our model also predicts a spike in the month of January, and gradually the time series settles down to its stable values. So this was a very brief introduction to forecasting, and next I would call upon Andy to discuss the long-term values of marketing campaigns. Over to you, Andy.
Thanks so much for stepping in there, Kushan, and thanks for the great introduction to Google Analytics and the R package for Google Analytics that you've helped develop.
Oh, no problem, Andy. So you have the floor.
All right, great. Thanks, Kushan. So as Kushan mentioned, I'll talk a little bit about calculating the long-term value of your marketing campaigns, just another example of how you can utilize some of the analysis and visualization tools with R to get a little bit more out of your Google Analytics data. So a typical analysis that you might do is sort of to look at a particular marketing action, whether it's an advertising campaign or something else, and see how many sessions or how many transactions resulted as a consequence of users clicking on that marketing campaign, whatever it might be. So in this example here, you see a report in Google Analytics that is probably a pretty familiar view to you. So as an example, the Fall 28-1C campaign led to 27 transactions and 458 sessions. And these are people that clicked on the Fall 28-1C marketing campaign and then immediately made a transaction. And this is great data, and it's great to do this analysis, but it's also possible that people might have discovered your business for the very first time from one of these marketing campaigns, right? In which case, yes, they may or may not have made a transaction in that initial visit to your website or to your app, but in reality, they might be driving a lot more long-term value for your business over time. So what we'd like to do is try to understand what is the actual long-term value being driven by some of your marketing actions, which will potentially be a lot greater than just looking at an individual session that has led directly to a conversion there. So, the graph that might be of interest here is actually this cumulative transactions, or or cumulative revenue or whatever the conversion might be. And what it is it's actually going to necessarily be an increasing graph where we are adding the incremental or daily transactions that have occurred from users of a particular campaign, so we can see sort of the full value over time that a particular marketing action, campaign, or really any other Google Analytics dimension has led. So let's take a look at how to construct such a graph, and we're going to need to start with the API query. So let's walk through this one at a time. So first we have the dimension is date, because we'd like to see this data over time, and the metrics are just transactions and transaction revenue. So this is a relatively straightforward dimension and metric set. I will note that if you're not an e-commerce company, then you can use potentially different metrics. So you can use a goal conversion value, goal completions if you're measuring goals. You can even use other engagement metrics if you're a publisher or something, some other business such as, say, page views or even simply sessions to see as a proxy sort of for the value that a given user or customer is adding to your business. Now the more complex part of this particular query is the segment. So there's a lot going on here. I'm going to just describe at a high level what it does, and then we'll dig into each one of the pieces to sort of deconstruct this to figure out exactly what's going on. So at a high level, we're going to look for users who are new visitors, so it's the first time they've ever visited the site between a particular date range. In this case here we have the first week of November, who came from a particular campaign, and then at some point thereafter made a transaction. So again, to recap, new visitors, people who have never been to the site, who visited for the first time from during a particular time window and from a particular campaign, and then made a transaction at some point in the future. So let's dig in a little bit deeper to exactly how that segment works. So the first condition here is users, and we're pulling the alternative. The two options here are users or sessions. The reason why we're pulling users is because we want to measure what these users are doing over time. So we're not just looking, in contrast to the analysis that I showed at the beginning, we're not just looking at an individual session. We're instead looking at all of the sessions from particular users. Then we're making it a sequence prefix. The other option is conditions. The reason why we're making it a sequence is because there is a set of sequential actions that we want to query these users. So the first step is visiting from a campaign in the first week of November, and then the second step is then making a purchase. And finally, we have sort of the next condition is this caret prefix, which says that it's necessarily going to be, that this condition is going to be true for the first hit of the first session. And the condition is new visitor in that first week of November coming from a given campaign. Now I will note that, and part of the reason why I'm walking through this is because it's definitely something that you'll want to customize for your business depending on what your campaign is, when you ran the campaign, things like that. Another condition here that I added that you may or may not want to include is the new visitor condition. So I like to think about this in terms of driving as almost a customer acquisition question. So we're driving customer acquisition from a given campaign. How many subsequent transactions did these new customers bring us? So that's sort of the context that I'm thinking about here, but you can definitely customize it depending on the needs of your particular analysis. And finally, the second sequence in this step is going to be then made a transaction. So we're just saying in some session, transactions was greater than 0, so made a transaction. So that's the segment. Definitely take some time to look at it, digest it, and certainly customize it for your own needs. So once we have this, we actually run 2 queries, one for 2 different campaigns to compare. It's possible that you might need to run this query more than once if you're looking to compare across multiple campaigns. So let's take a look at what the data looks like. So you can do that. It's always good to take a quick look at your data frames just using the head function in R. And here we just see that what it gives us is transactions over time. So despite a relatively complex segment, the output is relatively straightforward. For that set of users, how many transactions do they make every single day? Now, because the API returns to us in the form of just transactions per day, daily transactions or incremental transactions, what we'd like to do is turn this into a cumulative vector of data. So the way that we do that is to use the cumsum built-in function in R, which will simply just add each row to each other. So the first entry in the cumulative transactions vector will be 39. The second will be 39 plus 57. Then the third will be 39 plus 57 plus 351, and so on. So once we have this cumulative vector, we can plot them. And in this case, I actually did this for two different campaigns. I just labeled them Campaign A and Campaign B. And the result is actually very interesting. What we see is that initially, Campaign A has outperformed Campaign B, right, in those first few weeks of November. And if we're doing sort of the analysis just looking at how many transactions did Campaign A versus Campaign B drive immediately, we would have concluded that Campaign A was actually more effective. And depending on your goals, it actually might be more effective. It's possible that you're looking to optimize for sort of short-term value as opposed to long-term value, which is totally valid depending on your business. But if you were interested in sort of, okay, for this group of new users, which is ultimately driving the better set of customers in the long term, then it might be beneficial to look at this cumulative transactions plot. And what we see is that Campaign A begins to plateau around the beginning of November, whereas Campaign B actually continues to increase and has through the end of December. And we might want to continue to track this plot as we get more data for January as well. Because certainly 2 months is, you can say it's long-term value, but it's really not that long-term. So this is definitely something that you would want to continue to measure in potentially even a longer period of time. So doing this analysis, we can see actually that the long-term value of campaigns as measured using a cumulative transaction plot may be different than the short-term value that we see with a slightly more simple analysis. The plot here was generated rather simply in R using the plot function, and it certainly gets the job done, but it's not the most pretty, it's not the most fancy. But one of the things about R is that there actually are a lot of tools that are to make very beautiful visualizations relatively simply. So for that, I'm going to hand it back over to Kushan, who's going to talk about one of the best ways to make really nice visualizations in R, which is the ggplot2 function. So with that, I'll hand it over to Kushan.
Thank you, Andy. That was a really wonderful example. So you might have noted that in both of the examples, visualization was a very important part of the analysis routine. So you might be willing to just perform an exploratory plot to just understand the characteristics of your data, as we did in the first example. Or in this case, the plot actually serves the purpose of inference, and the role of this plot is to convey the results to some of your colleagues. Across both of these two workflows, R has this ggplot2 package, which is actually able to match both of these workflows. You could either use ggplot2 to make very basic exploratory plots, or you could actually polish these plots to make them, to format them, and maybe use them as a part of your presentations or dashboards. So quick with that, it makes sense to give you a brief background into what ggplot2 is. GG stands for the grammar of graphics, which was a particular idea advocated by Wilkinson, and it was implemented in R by Professor Hadley Wickham. So what grammar of graphics tells us is that we can decompose a plot into certain constituents, and we can sort of use this particular decomposition approach to add new layers to plots and make them more publish worthy. So ggplot2 allows you to create very sophisticated graphs in a few lines of R code, and I demonstrate some functionality of ggplot2. There is a bit of a learning curve associated with ggplot2, but once you have gotten the hang of it, it is pretty much worthwhile to use it in some of your visualizations. So we start with creating a very basic time series plot in ggplot2, which is one of the most fundamental plots that you will encounter. This is what the syntax looks like. we already had the data. This particular plot is for item revenue, the data that we just extracted, and we need to first initialize ggplot2 with the data inside our data frame, and this is done with the help of the ggplot2 function. Once you have mapped the data, the first layer that we add to it is a geom_line, and inside of that layer we map two variables, x equal to date, that is the date is mapped to the x-axis and y is the y-axis is mapped to item revenue. So let us decompose some of this syntaxes and then quickly jump to R, and so that I can show you another example inside of R itself. So the first step that we saw is to create a ggplot2 base object and populate it with data, which is done using this function. Then we can consecutively keep on stacking the base layer with a couple of the base plot with a couple of layers. In this case, we are concerned with having a time series, which is a line chart. So we have a geom_line, and there could be other geoms as well. You could, depending on your data and the analysis that you wish to carry out, you would either have a geom_bar, a geom_point for a scatter plot, or you could also do a geom_histogram in case if you want to visualize the distribution of your data. The next step is to, once you've selected the particular geom, we can map data to its aesthetics. So in this case, we are trying to map the x-axis to date and the y-axis to item revenue. There are also a lot of additional plotting options. You could try and manipulate all the aspects of your plot, be it the plot title, be it the axis titles, axis format, axis text, and so on and so forth. With that, we can go on to R, and I'll show you how to carry out another bar plot as well. So first step is to load the ggplot2 library. I'll just clear up this section of the screen because that is where the plots will be appearing. Now I have already extracted some data prior to this example, and this is what the data looks like. So what we have right now is we have the transaction revenue broken down by first one being the user type and the second one being the device category. So with this, we want to understand comparative transaction revenue between new versus returning visitors. And in order to plot that as a bar chart, we follow the same convention. We initialize the ggplot2 objects with our data frame, and we map two variables. We map user type to the x-axis and the transaction revenue to the y-axis. And this is the layer, this is the geom that we're selecting. Now this particular argument, stat is equal to identity, it maps the height of the bar to the transaction revenue on the y-axis. This will become more clear as I execute this command, and you can see the plot which occurs as a result of that. So this is a very basic bar chart, but you might have noticed that these numbers on the y-axis are occurring in scientific notation. This is not related to visualization, but you could actually turn it off with the help of the options command. Now we can replicate that plot again to see that those numbers get displayed actually as integers. So in the next step, we want to have the same bar chart, but we want to break it down by the device category. And ggplot2 has this particular functionality called facets, in which you can break down your existing plot with an additional categorical variable. The category is device category. So most of the syntax is pretty much the same that we had in the last slide, but we are just adding a facet_wrap option to it, and this is how the results look like. So we are able to break down the transaction revenue both by new versus returning visitors as well as by desktop, mobile, and tablet with the help of facet_wrap. But if you were to include this plot in inside some of your dashboards, you would definitely want to have different colors mapped to these bars that we have over here. And ggplot2 also makes color mapping very simple. We can persist with the exact same code in the previous command and just add a couple of one additional argument called fill. We'll try to map fill to the user type. There you have it. So in just 3 steps, we are able to take a very simple plot and we could customize it and make it a bit of publication worthy. ggplot2 has various very extensive options, and I suggest you definitely take a look at the documentation. We have also covered ggplot2 in some of the examples on our blog, so you might want to check them out as well. So here at this point we conclude with the examples, but before we get to the conclusion of the webinar, I would want to share some of the best practices that I have found very useful in interacting with the Google Analytics API. You might have noted in all these examples, the dimensions and metrics have a bit of a different naming convention than you would observe in the user interface. Specifically, these dimensions and metrics are in camel case, and this convention has to be followed whenever you are entering the dimension metric names inside of R as well. Moreover, there are certain permissible sets of dimension metric names that are only that you can only query. Some of them are not permitted, and there is a list on the Google Analytics developer channel where you can see all the permissible dimension and metric combinations. Sometimes it happens that either due to misspelling of a particular dimension or metric name, or maybe due to a wrong combination of dimension metric, some of your queries start failing, and in this case it becomes more worthwhile to actually test your queries before working them out in R. And there is this neat GUI developed by the Google Analytics developer team. It is called a Query Feed Explorer, and you could use it to test all your queries. Once your queries start passing, you could copy and paste the parameters in R and then carry on with the rest of your analysis. Regarding RGoogle Analytics, it is in a very early stage, and you might bump into some issues. I suggest you post your issues on the issue tracker on GitHub so that I can take a look at those issues and then try and solve them in the later and the upcoming versions. In case if you have any questions in general regarding the Google Analytics API, or want to share some ideas about how you're using the API for your workflows, I suggest you take a look at the reporting API forum, where there are a lot of active developers who would be very readily available to answer or help you with your API queries. We could cover a majority of the stuff in R, but as such there is a lot of stuff that we couldn't cover due to the time constraints that we had. We have made a bit.ly bundle of all the useful links and resources that we have been using internally in our organization as well, and you can check this out and experiment with some of the additional resources to further your learning inside of R. So now we come to the last section, which is Q&A. Before that, I just announce the next webinar is titled "Everything You Need to Know About GTM Version 2." It's scheduled on February 18th at 11 a.m. Pacific time. We have Phil Pierce. Phil is a web analyst and an SEO expert, and you can register for this particular webinar using this link. Within the time constraints, we should be able to answer a couple of questions. The first question that we have is that how large data sets can R scale to? Andy, do you want to take up that question?
You know, offhand, I'm not 100% sure. I think it will depend a lot on the machine that you're using, as well as the nature of the data set. But for most of the Google Analytics data sets that most of the data sets that you'll be retrieving from Google Analytics, R will definitely be able to handle them. Just because generally with the API, you'll be dealing with probably at most a few million records. So, you know, maybe even into the tens of millions, and that should be just fine.
Correct. Just to add to Andy's point, R processes all your data into memory, and therefore you are restricted by the size of your memory while processing your data. So in case if you have a particularly larger data set, maybe I would recommend you either incrementally process it by storing it into a database and then running queries on it, or maybe use some of the advanced packages, or maybe have a look at MapReduce. The second question is, you mentioned that there are some techniques through which the API is able to handle large queries. Can you give some of the examples of those techniques, Andy?
Sure. So depending on the size of your data set, it's possible that in Google Analytics, it's possible there will be subject to some sampling. In particular, if you are querying, the query that you're looking at has more than 500,000 sessions. So one of the techniques that is popular with the API is to query for individual days, because then it's possible that an individual day will be with less than 500,000 sessions, or at least a fewer amount, in which case you'll have more of your data included in the query. So this technique is generally known as, and then combine the data afterwards. So you query for individual days and then combine afterwards. So this technique is known as pagination, and what's nice is actually the RGoogleAnalytics library that we've been discussing today has this feature built in. So if you are experiencing data sampling, then you can potentially use the API with this pagination feature to get around this. The way that you'll know if you are experiencing sampling is you can either, if you're in the Google Analytics interface, there will be a little yellow dialog at the top of the report that says the data is based, this is based on sample data, and we'll say the rate and so on. And if you're using the API, there's actually a field that's returned that will tell you whether or not there's sample data in the request.
Absolutely, and since our Google Analytics it basically echoes all the messages of the API. So in case if you're running into sampling, that particular message will be displayed into our console, and you would then be able to detect whether your data is getting sampled or not. So within the time constraints, we are currently only able to answer a couple of your queries, but we will definitely get back to you via email to answer all the rest of your queries. So this brings us to the end of the webinar. Thank you, Andy, for joining us and giving us your valuable time. Thank you all of you, and we hope to meet you in our future webinars as well.
Thanks so much, Kushan, and thanks so much to Tatvic for hosting.
Have a great day, Andy. Thank you.